Hello, let's discuss how to factor using difference of two squares. Here we have a square minus b square. This can always be factored as product of their sums, that means a plus b times difference of their sums, a minus b. You can try it. You can try from this side, expand a plus b times a minus b, and then simplify it. You will get a square minus b square. So try it on your own. Let's take some very simple examples. So instead of doing a and b, I'll take some numbers, okay? Let's say we have x minus 3 times x plus 3. Now if I expand it, x times x is x square, x plus 3 will give me 3x. Now let me multiply with minus 3. So minus 3 times x is minus 3x, and minus 3 times plus 3 is minus 9. Now you will see plus 3x and minus 3x become 0. So you are left with x square minus 9. See, x square minus 3 square. So when I say a square minus b square, here a is x and b is 3. So you want to factor them? Just multiply their differences and sum. X minus 3 times x plus 3 will give you x square minus 3 square. So that's how we do difference of squares factoring. Nothing can be easier than this. Well, at times you may have, for example, 4x square minus, let's say, 81. Now you can write this as equal to 2x whole square, correct? So 2x whole square will give you 4x square minus 9 square, correct? Again, it becomes difference of squares, and you can factor this. How will you factor it? Write their sums and products, multiply them. So 2x is our a, and our b is 9 here. So we'll write 2x plus 9 times 2x minus 9. Once you do that, then you have factored your difference of squares. So it may not be very obvious to look at, but if you really convert them into squares, then you can always do it. I hope you remember radicals. At times you may have something like this. Now let me give you a complicated one. This is 3x square minus, let's say, number 18. Now you can take 3 common. Let's do that first. So you get x square minus 3 times 6. But see, 6 is not a perfect square, correct? Well, what you can do in such cases is that you can write 6 as a square of square root 6. X square minus square root 6 square, correct? So we ultimately got differences of squares, and this can be factored as 3 times x square plus square root 6, x plus square root 6 times x minus square root 6. I hope you remember these radicals. Square of this radical is 6, correct? So that's how you can factor them. So you may not get always a whole number, but you get a real number. So in the domain of real number, you can always factor difference of squares. Here I have a couple examples for you, which you should try. Okay, so I will not give solutions to each problem here, but I can tell you how to do some of them. This is similar kind as we did here, right? You remember 4x square? So 4x square, I can write this as 2x whole square, correct? And 25 is square of 5. So you can write this as 2x plus 5 times 2x minus 5. So you get your answer. How about this place? Now here is something common. Look for a common factor. Maybe you can say 3 is common, correct? Yes, 3 is common. So let me do the first step for you here. We can write this as 3 times, let me use a square bracket just for clarity. 27 divided by 3 is 9, right? So you get 9x square minus, if you divide 48 by 3, what do you get? 3 times 1 is 3 and then 18 is 16. 3 times 6 is 18. So you get this. Now this is familiar, right? You can factor this as, this is 3x whole square. So let me write 3x whole square minus 4 square for you. Now the last step you can always fill in. Last step is so clear. 3 times, this is difference of squares where a and b are, a is 3x and b is 4. So I can write this as 3x plus 4 times 3x minus 4, correct? So that's how you can factor. So there is a group, correct? You can factor out a number first and then get a difference of square. That is also possible, correct? This one and this one are similar. So let me have a closer look at this, correct? Here we can again take 3 common, correct? Try it out. Take 3 common, then you have x square, x minus 1. This is the square. Here we don't have x or a single term, but a factor itself, x minus 1, okay? So try this out. You can stop the video at this stage, do these 2 problems, and then look into my solution, okay? That will be good. Now let me do it for you. So what I will do here, I will take 3 common. So if I take 3 common, to avoid type of brackets, I am using square bracket now. Do you see that? So I'll have x minus 1 whole square minus 12 divided by 3 is what? 4. Now, this is difference of square. Can you recognize it? This could be written as 2 square. Correct. It is x minus 1 whole square minus 2 square. Is that okay? Now you can factor it using your difference of squares. This is x minus 1 plus 2 times x minus 1 minus 2. Do you see? For a, what did I take? I took the value x minus 1 as my a. Do you see that? X minus 1 as my a. Correct? So that is how you can factor it. And now you can simplify this to get your answer. So you get 3 times minus 1 plus 2 is plus 1. So you write x plus 1 times minus 1 minus 2 is minus 3. So that's your final answer. Correct? Yes. Now this question. Here we have x to the power of 4 minus 1. X to the power of 4 is square of x squared. So I can write this as, let me write here as x, okay, let's do it here. X square whole square minus 1, okay. So 1 is square of itself. So I can write this as x square plus 1 times x square minus 1. Is that okay? This is 1 square. And what is a for me here? A is x square. So I'm using x square, not just x. Do you see that? Right. Well, this is also difference of square, right? X square minus 1. So we can further factor it and get our final answer. X square plus 1 times, this will be x plus 1 times x minus 1. So that's our final answer. Now, can you factor x square plus 1? No, not in the domain of real numbers. X square plus 1, it is not difference of squares. There is a plus sign in between. So be careful, okay? You can't factor this one. Well, there are lots of application of this simple factoring process. You can find product of big numbers using factoring. Let me give you one example. For example, if you have to multiply, let's say, 18 times 22. How will you do it? Let's say you have to multiply 18 and 22. How will you do? You can write this as difference of squares. I can write 18 as 20 minus 2 and 22 as 20 plus 2, correct? So this becomes product of difference and sum. So product of difference and sum could be written as this, right? And this is what? A square minus B square. So this could be 20 square minus 2 square. 20 square is 400, right? So you get 400 minus 2 square is 4. So it is 396. So you can do products and big products using simpler numbers, right? So it can be used in many different ways. Anyway, here I have a set of questions for you. So this is a tutorial sheet, okay? You are supposed to practice. Once you practice, you will get a lot of knowledge and first-hand experience on solving these kinds of factoring problems. And you'll be an expert on this soon. So have a look on these questions. Correct? Make a copy of these questions and try them out. You should be in a position to solve them since we have already covered examples of doing similar types. Correct? Okay. Thank you.